Here's how China spent $27 billion to build one of the longest heavy-haul railways in the world. Not around the Gobi Desert, but straight through it. The Haoji Railway runs 1,814 kilometers from Inner Mongolia's coalfields to factories in central China, cutting across shifting sand, mountain ranges, and two of the country's major rivers. What it reveals is how Beijing uses steel and concrete to redraw the economic map of the world's second-largest economy. China's coal sits in the wrong place, and that simple fact drives everything that follows. Roughly 69% of China's coal comes from three northern regions: Inner Mongolia, Shaanxi, and Shanxi, while the factories that burn it are concentrated up to 1,500 kilometers away in central and southern provinces. For decades, this spatial mismatch created a logistics nightmare. Coal would travel by train to ports on the Bohai Sea, get loaded onto ships, sail down the coast, then transfer to river barges before finally reaching inland factories. The entire journey could take around 20 days. Beijing needed a direct route. They finished it in September 2019, after 4 years of construction. Haoji South Station in Ordos, Inner Mongolia, connects to Jian Station in Jiangxi Province through an 1,800-plus kilometer line that crosses 7 provinces and passes through 77 stations. Design capacity sits at 200 million tons of coal per year, roughly 547,000 tons every single day. What they had to build through shows the scale of this project. The railway cuts across the Mu-Us Desert, where shifting sand dunes can bury track in weeks if you don't engineer around them. Crossing Loess Plateau required specialized foundations because the crumbly soil doesn't behave like normal ground. 3 separate mountain ranges stood in the way: the Luliang, Zhongtiao, and Qinling mountains. So engineers drilled 229 tunnels, totaling about 468 kilometers. Nearly 300 miles underground, with 10 tunnels longer than 10 kilometers each. And that's before you even count the bridges. 770 large and medium-sized bridges span roughly 381 kilometers, with 10 classified as extra-large structures longer than 5 kilometers. The line crosses the Yellow River twice and the Yangtze once. The Sanmenxia Bridge had to be built as a double-deck structure carrying both road and rail, while the Hanjiang Bridge became a cable-stayed span stretching more than 5 kilometers. An 8-kilometer viaduct in Hejin ranks among the longest continuous elevated sections on the line. Add it all up, and bridges and tunnels make up nearly 47% of the railway, around 850 kilometers of track that never touches natural ground. This wasn't just pouring concrete and laying rail. During construction, Chinese railway companies developed more than 100 new construction methods, obtained over 160 patents, and won dozens of science and technology awards. They built what they called the world's first large-section profiled earth pressure balance shield machine, specifically for drilling through the complex geology along the route. Once the line opened, it ran on intelligent integrated dispatching, paired with smart traction power supply and automated monitoring that tracks the health of infrastructure along every kilometer. The payoff was immediate in one dimension: time. Transport dropped from 20 days to 2. Coal loaded onto a train in Inner Mongolia can now reach a power plant in Hubei province in about 48 hours, with no port transfers, no ship delays, and no waiting for river barges. Just direct rail delivery to the factory gate. But there's a paradox here. China approved this line in 2014, just as its renewable energy growth was accelerating and coal's share of the energy mix was starting to fall. So why pour $27 billion into coal infrastructure when the future supposedly belongs to wind and solar? Energy security explains the decision. More than half of China's total energy still comes from coal, and when Haoji opened in 2019, the country consumed over 4 billion metric tons, more than the rest of the world combined. China has the world's third-largest coal reserves, yet it became a net coal importer in 2009. By the mid-2020s, coal imports had climbed into the hundreds of millions of tons annually, more than double what India brings in. China isn't running out of coal. The problem is getting it where it needs to go without relying on vulnerable coastal shipping lanes. 90% of China's exports are manufactured in coastal provinces, which means most of its economic output sits exposed to naval blockade, port congestion, or disruptions to sea lanes. The Malacca Strait funnels much of China's energy and raw materials through a choke point ultimately controlled by other powers. If you're planning long-term strategy in Beijing, you spend a lot of time thinking about what happens if those routes get cut. The Haoji Railway reduces that vulnerability. It strengthens domestic energy circulation and makes inland manufacturing more competitive with the coast. That fits neatly into what Beijing calls its dual circulation strategy, building domestic supply chains that don't depend on international logistics. By moving coal north to south over land instead of by sea, Haoji bypasses the coastal system entirely. Population distribution adds another layer. China's Go West policy aims to shift development inland and ease pressure on overcrowded coastal megacities. But around 90% of manufacturing still clusters near the coast, because that's where the ports are. A factory near Shanghai or Shenzhen sits close to global markets. Set it up in Shanxi or Henan, and you pay more to move goods, unless you build infrastructure that makes inland locations competitive. Haoji was designed to do exactly that. Construction created more than 2 million square meters of new farmland by reclaiming soil, employed thousands of workers from underdeveloped counties, and built 21 coal terminals with integrated logistics facilities. The line connects to existing tracks at a dozen junctions, tying into the broader Chinese rail network in what planners describe as a massive system to boost cross-regional transport capacity. Build infrastructure this way, and it becomes regional policy in steel and concrete. In theory, it works. In practice, the numbers tell a more complicated story. Design capacity sits at 200 million tons per year, but in its first month of operation, Haoji carried only about 35,000 tons per day, roughly 6% of what it was built for. China State Railway Group set a target of 60 million tons for 2020, about 30% of capacity, but available reports suggest the line didn't hit that number. Internal forecasts pointed closer to 18 to 25 million tons. The underutilization was so serious that some shareholders reportedly tried to pull their money. The railway itself works, the system around it doesn't. The weak link is what planners call the collection distribution system, the smaller rail lines, truck routes, terminals, and storage that feed coal into the main artery and then distribute it on the other end. Imagine Haoji as a major blood vessel. If the capillaries don't function, it doesn't matter how strong the artery is. Coal mines need feeder lines to connect to Haoji. Factories need spur tracks to receive deliveries. Storage yards, loading equipment, and logistics networks all have to be in place. Much of that lagged behind the main line's opening. Then there's cost. Haoji charges a rate per ton-kilometer that's significantly higher than the national average. Even though rail is faster than sea, coastal shipping still wins on price over long distances. A factory in Jiangxi might get coal sooner by rail, but if the ship route costs less, the spreadsheet usually decides. One industry insider put it bluntly: there's no profit in moving coal to southern China on this railway, at least not yet. So you end up with $27 billion of infrastructure running far below capacity, while China still imports record amounts of coal and ships domestic coal down the coast. It's a mismatch between planning and execution, between strategic vision and market reality. But Haoji doesn't exist in isolation. China already operates a web of major coal freight railways that together move over 1 billion tons of coal every year. The Dakin Railway, opened in 1992, runs about 650 kilometers from Datong in Shanxi to Qinhuangdao Port on the Bohai Sea. Fully electrified and double-tracked, it has carried more coal than any other railway in the world, averaging well over 1 million tons per day over decades of operation. The Shuohuang Railway stretches nearly 600 kilometers from Shanxi to Huanghua Port and transports over 100 million tons annually. Other lines, Shenzhou, Dajun, Wari, Mengji, and more, add hundreds of millions of tons of capacity. Haoji is the newest link in this network, and importantly, the first major north-south coal corridor explicitly designed to bypass the coast. Underperformance today doesn't change the logic behind it. China often builds infrastructure decades ahead of demand. Capacity fills in gradually. Immediate profitability isn't always the point. Strategic positioning is. And coal isn't the only thing moving. About 150 kilometers northwest of Baotou lies the Bayan Obo mining district, home to the world's largest rare earth element mine. Bayan Obo accounts for a significant share of known global rare earth reserves and produces a large fraction of the world's supply. These are the materials that go into smartphones, wind turbines, electric vehicles, and military hardware. The mine has been operating since the 1950s and contains enormous reserves of rare earths, alongside iron ore, niobium, and fluorite. China also controls the majority of global rare earth processing capacity, and Bayan Obo is central to that. The environmental costs are staggering. Each ton of rare earths processed generates large amounts of waste gas, acidic wastewater, and radioactive byproducts. But strategically, rare earths matter as much as oil. Without them, you can't build modern electronics or many clean energy technologies. The same railway network that moves coal also moves rare earths, iron ore, copper concentrate, and other minerals from Inner Mongolia's interior to factories. This is dual-use infrastructure by design, which multiplies its strategic value. And the network keeps expanding. In May 2025, construction began on a new cross-border railway linking Ganki Maodu port in Inner Mongolia with Gashun Sukhait in Mongolia. It's less than 20 kilometers long, but it's only the second cross-border railway between the two countries in nearly 70 years. This line will increase coal transport capacity by tens of millions of tons per year and generate substantial revenue for Mongolia, boosting its GDP growth. It ties Mongolia's resource exports more tightly to Chinese demand and Chinese infrastructure. Meanwhile, Mongolia's Tavan Tolgoi coal field, one of the world's largest untapped coal deposits, now connects by rail to the Chinese border via a 200-plus kilometer line that opened in 2022. Transport costs dropped dramatically compared to trucking, locking in economic dependence on Chinese rail. These railways don't just move coal, they create dependencies. They anchor economic relationships and make suppliers reliant on Chinese logistics, Chinese financing, and Chinese technical standards. This is infrastructure as foreign policy. Back in Inner Mongolia, Chinese railway companies are already testing ways to increase capacity without laying new track. In December 2025, they ran a 35,000-ton heavy-haul train on the Baotou-Shenmu Railway, using what they call virtual coupling. Instead of one giant train, 7 5,000-ton trains operate as a synchronized unit through automated control systems. They dynamically assemble into one formation, travel together, then automatically decouple at their destinations. This kind of technology could boost capacity on existing lines by 50% or more without adding new tracks, turning underutilized infrastructure into a strategic asset over time, which is exactly the bet China is making. Because in the end, the Haoji Railway is not just about moving coal faster. It's about reducing dependence on vulnerable coastal bottlenecks. It's about making inland provinces economically competitive. It's about anchoring heavy industry closer to raw materials and controlling resource flows in ways that strengthen domestic circulation while reducing exposure to external pressure. For centuries, geography dictated economics. Ports meant power. Coastal access meant wealth. But when you build infrastructure that cuts through deserts and mountains and makes overland transport faster and more reliable than the sea, you start to rewrite those rules. $27 billion bought China a railway that currently underperforms and may take decades to justify on paper. But the track is laid, the bridges and tunnels exist, the capacity is waiting. When demand eventually catches up, the Haoji Railway stands ready to serve as the backbone of an inland industrial corridor that doesn't depend on anyone else's sea lanes. That's the long game, and that's what infrastructure as strategy looks like when you commit to it. See you on the next one.